Okay, like I said in class today, the pictures of what we're going to do today look exactly like what we did yesterday. But instead of finding measures of arcs and angles, we're going to find measures of segments. Okay? So the three, like I said, there's going to be three, just like there were for angles. Um, the first one is a chord product theorem. And that says that if two chords intersect inside a circle, okay, so do you see how chord CE and chord AD intersect? Okay, then the product of the pieces of the chord are equal. So if you look over here, AB, this piece right here, times BD equals the product of CB and BE. All right. I have some examples. Let's try an application here first. So here's an actual application I came across a long time ago. Archaeologists found this piece of a shield, and they wanted to know. They were trying to figure out how actually big it was. Okay, so they drew a chord, and then they drew its perpendicular bisector, and they found to find the diameter of the chord. So they drew a circle around what the outside edges of the shield. Okay, then they drew the perpendicular bisector somewhere. There we go, and the chord. Okay, and they want to find the diameter of the chord. All right, so come on. There we go. That's 3 inches. Okay, there we go. 5 inches. Okay, and it's a perpendicular bisector, so we know that's 5, so is this. Okay, and this is the piece we don't know. Okay, so we can use uh, this new chord theorem to figure out the missing length. So we know from here, from right in this point to this intersection point is 3 times x, and we know that's equal to this this piece of the chord that goes the other direction, and this piece of the chord, which is also 5. So we get 3x equals 25. So x is equal to 8 1/3. Okay, so the diameter, because this is obviously a perpendicular bisector, so the diameter is 8 1/3 and 3. So that's 11 1/3 inches, or feet, or whatever. 11 inches, yeah. 11 1/3 inches. Okay? Does everybody understand that's, these are we know this is a perpendicular bisector because the distance from here to here and from here to here are the same, so those must be the radii. And we know that a radii that intersects a chord is perpendicular bisector. All right, so that would be an application of the chord theorem, that the product of these two pieces of the chord equal the product of the other two pieces of the other chord. All right, the secant product theorem says, well, first of all, we need a little bit of vocabulary. The part of a secant that's inside the circle we call the secant segment, and the parts that are outside the circle are called the external secant segments. Okay, so secant segments inside the circle, external, outside, secant segments are outside the circle. All right, so the secant product theorem says that if you've got two secants, which we do here, everybody see they both start at E, and then they go through the circle at B and A here and D and C here. the product of the whole secant here times the external secant segment is equal to this whole external, or it's a whole secant here with just the external secant segment there. All right, so if you look at this formula, it might help you. So AE, which is the whole thing, right? AE, this whole thing, times BE, just this piece, is equal to CE, this whole thing, times DE, just that piece. All right? Again, that's just going to be a memorizing thing. All right. Then the only one left is when we have a secant and a tangent. Okay? Because remember, like day one, we learned what happens when we have a tangent. Remember? These two are equal. So we've already covered tangent a long time ago. So we've got chord, secant, and now we've got, and we already did tangent, so now we've got tangent, secant. And the tangent secant is a lot like the secant. It's just that this part down here, this CD, doesn't have a part that goes through the circle. So so we're still going to do the whole thing, AC times BC, but on the other side, that's going to be equal to just CD squared. Okay, because there's only like one piece on this side, like it's missing a piece. So instead, we just multiply by itself twice. So it's AC times BC equals CD squared. All right, so those are the three formulas. Let's see if we can work some problems here. This is a secant. So this whole side is x plus 5, okay, times just the outside, which is 5, is equal to this whole side, which is 12, times just the outside, which is 6. All right, so if I distribute, I get 5x plus 25 equals 72. I'm going to subtract 25 from both sides, and I get 5x equals, let's see, that's 47. So x is equal to 9 2/5. Okay, that's secant. Now, for chord over here, we know that the two pieces of one chord, the product of the two pieces equals the product of the two pieces of the other chord. So 4 times x is equal to 3 times 9. So 4x equals 27. So x equals 7 1/4. Right? 28? No, 27. Sorry. Oh my goodness. My math is, I just lost it. 3 times 9 is 27. So that's 24. So that's 6 3/4. Sorry. That's what I get for trying to do it in my head. All right, and the last one is secant tangent, and that is, again, the whole outside, which is x plus 4 times just the outside, which is 4. And remember, the tangent doesn't have an inside, so instead we're just going to square that one. So I get 4x plus 16 equals 36. So 4x is equal to 20, and x is 5. All right. So again, the pictures look the same, but we're finding different things. And we're not finding angles anymore. We're finding pieces of the sides. All right?